So, welcome everybody to my talk. Welcome everybody, 3 people that came. Thank you for coming, really. I really thank you. So, today I'm about to talk about creating some awesome experience for you on Eclipse for Scala. I want to explain what we are doing to provide an awesome experience. What's the current status and what we can provide for you. Okay. So this will probably be not needed because there's this app that allows you to ask questions during the talk, and we can just skip it because there's 3 people here. Hi, why am I here? So my name is Tomasz and I work at VirtusLab. That's there in the middle. And we are working with Scala Center, which is a non-profit organization that tries to provide proper solutions for the Scala community that allow developers to work better, to work more efficient. And there's different initiatives being pursued inside of Scala Center itself. And we reached out as VirtusLab to Scala Center to help out. And because of that cooperation comes our work on metals. Okay. There's more people working on metals. There's the guy in the top, that's Olafur, who is the author of metals. There's Gabriele, who spends a lot of his free time on working on metals. There's Marek, another guy from VirtusLab, that's the second one. There's Edmundo, who's actually working on the Eclipse integration. He's doing a lot of nice work there. And there's Jorge, who's working on Bloop, which is an integral part of metals, but I'll get back to that. Okay. So let's talk about metals itself. Yeah, it's not right. So LSP, let's start what language server protocol actually is. So this is a specification of how to interact between the client editor, the client is the editor, and the server, which here is metals. And there's this really nice specification on the Microsoft website. I think that belongs to Microsoft. It's open source, but mainly maintained by Microsoft. And this is pretty good specification with all the information about what requests can be served by the server. And it's all done using JSON RPC, which is pretty nice because you can actually trace that and look into the logs very easily. Okay, yeah. So LSP provides you with your favorite language in one of your favorite editors. Currently in Metals, we support 6 editors. That's VS Code, there's Emacs, Vim, Sublime Text, obviously Eclipse, and Atom. The Eclipse integration is still being worked on because the client itself is not yet, doesn't have all the features yet. So there's still some work to be done there. But if you want to also use any of the other tools, they should all be working. The VS Code one is probably the most featureful because the LSP client itself for VS Code is also developed by Microsoft, which makes it also like the top priority for them. Okay, so there's this nice tool on the specification website where you can actually get your logs that are the requests saved into a file. You can put that log into the website and have all the information on how the client interacts with the server. And you can see here the start of the communication. It's initialized, sent from the client to the server, then server response, then they talk about registering some capabilities. So each LSP client actually talks with the server, tells them what they support, what kind of features are supported. Server in turn responds with the same so that they know what they can and what they can't use from each other, so to say. Later on, it's a later communication cycle. There's asking for code lengths, there's asking for document highlights. So it's all very easy, actually. Just requests being served from the server to the client with explaining the language to the client itself. So it's actually very easy, and because of that, we are able to have it in all those different editors in many different places. I'm pretty sure there's a lot of possible work for getting it on remote. Actually, there's something already working, which I'll be talking a bit later. But this is mostly it. That's how it works. For metals itself, we have three main pieces. So that's first one is build tools. In Scala, we have many different build tools. Currently I count 8, which is crazy. As you can see, this is a bit of a problem because there's a lot of those build tools. But currently in metals, as I said, we support 6. That's Gradle, SBT, SID, which is a totally new, I think, one. Maven, there's Fury from John Pretty, which is a really interesting new build tool that works on sources. So all the dependencies are sources. And there's also the build tool Mill. So we support all of those build tools in metals. But the question is, how can we actually support that? Because, I mean, that's a lot of integration. That's 6 different integrations, and like it's a bit crazy to make it all work. But I was talking about Bloop. This is the thing that enables each of those build tools to work with metals. Each of those build tools are able to generate configuration for Bloop. 4 of them are done automatically when we start up metals. Fury and SID can create the configuration files, but it's not yet automatically imported by metals. You will have to run it yourself. But it's not really a big issue, and both of those build tools are still, I think, for sure Fury is being worked on heavily, and SID I'm also pretty sure there's a lot of work being done. But thanks to that, the people, for example, in SID, they only needed to provide integration with Bloop itself, and thanks to that, they already have the support in the IDE in metals, which is pretty amazing. Okay, let's talk more about Bloop. So, Bloop is a Scala build server. It's communicates with metals or any other. It also can communicate with IntelliJ. It connects via another JSON RPC protocol, build server protocol. And that protocol is very similar to how LSP works. And the difference is it provides us the information about what the build is like. So what are the dependencies, where are the sources, everything like that. It also enables us to compile anything in metals. And as I said, the build tools only need to create configuration files for Bloop. We can later start Bloop ourselves, or people can start their own server, and it just works. Okay, so that's solved. We have all the build tools. They just need to provide the configuration files for us, and we communicate with the build tools via, with Bloop via BSP. Okay, next thing we need is some semantic information to create indexes, to find references, to find implementations. So the way we do it in the Scala world is usually using semantic DB. The only problem with that is that if somebody doesn't know, semantic DB provides information about symbols and their occurrences, their definitions in protobuf format. So those are binary files that are created by a compiler plugin during the compile, saved to the file system along the classes, and you can then easily read them, and they are pretty fast to work with. But the problem here is that we need to compile everything. So this is a bit of a problem if we're providing an interactive experience in IDE, so in editors. So what can we do, actually? So Bloop is actually compiling everything really fast. It's a JITed compiler. It's hot compiler. It has the Scala compiler inside, so it's actually not Bloop that is hot, but Scala compiler that is hot. So the server runs continuously, and not like in build-tools that if you start the build-tool, they start the compiler somewhere in the background, and it starts slow because it's not JITed. Bloop runs all the time, and thanks to that, the feedback is pretty fast. We get the semantic DB files created really quickly, and also, as an added bonus, all the errors are the same as you would expect in the build tool. So it's not like you have something in IntelliJ or somewhere else, and you're thinking that maybe it does work in the build tool. It will not work in the build tool because it's the same. The class path, everything is the same. Okay. So that's an example. So that's in Eclipse itself, and it's pretty fast. I made an error, it sent a request to compile, and then I fixed it and saved, and it's pretty fast feedback actually, and we managed to convince Martin Oderski that it's actually really nice to compile on save, and he's pretty convinced to allow to use metals, because this is a really quick feedback cycle, and a lot of the times if you're doing some code, it will sometimes show you some errors despite you didn't even finish writing your code, and it's often not very useful. But here, if you compile and save and it's very fast, I'm using metals to work on metals, so I got used to that feedback cycle, and I find it much more convenient than just errors everywhere. The only errors we show you at the continuously are parser errors. So if the syntax is wrong, because that is also very useful to have at least the syntax errors quickly, and all the type errors and everything like that only when you save. Okay. So the last piece to the puzzle of metals is the Scala presentation compiler. We need Scala presentation compiler for completions. It provides member and scope completions that we can use inside metals. We also use it for some definitions, for finding definitions. And the Scala presentation compiler is actually really nice. The only problem is it's very hard to make it all work in an interactive environment because everything changes. We need to feed the Scala compiler current information, and sometimes the state inside of this presentation compiler can even break because it sometimes sends just a shutdown request. So it's a bit of a problem to keep the presentation compiler going on all the time. There's a lot of tools using the Scala presentation compiler already. That's Ammonite, the rep itself is using the presentation compiler. Scala IDE is using the presentation compiler. So it's well tested. We just need to pack it in a thread so that we can restart it anytime anything breaks or we'll send a shutdown request. And honestly, it's not probably the best solution, but I mean, the complexity of making sure everything works in the interactive environment, it's really not worth the effort while we running in a thread and just restarting is enough for us, and it didn't yet provide us with any problems. Okay, so those are the three pieces I was talking about. All of those pieces create metals itself. Without any of them, it wouldn't work. And what works? So the green features are already implemented. So those are the LSP features that we can implement. We get some new coming in that are already available in snapshots. So fine implementation, code lenses, and run test. But I'll talk about it more. Okay, so metals in action. Hopefully you can see everything because the slides are quite big now. But this is some completions we get. So I was saying that we have base completions like scope and member completions from Scala presentation compiler, but it's not all we do. We change those completions to enable some more complex stuff like exhaustive matches in pattern matching. Then it will actually generate you all the classes that there can be. You can also do it case-by-case basis. So if you don't want to use everything, you can just write case and it will show you all the options you can use. The completions are pretty fast thanks to the presentation compiler, and thanks to the fact that we enrich them. They're also pretty. Some of them are really complex. At the end, you can also see that we are actually using formattings from Scala FMT, which is also enabled in Eclipse itself. Okay, next we get definition hover. It's not working perfectly, as you can see, because the hover information is shown via markup, and the markup is not showing really well yet in the Eclipse client, but we also have go to definition on local symbols and on outside symbols from libraries. The way we do it for libraries is that actually each time we import build into metals into Bloop actually, we download also the sources. So when we want to go to definition of something in a library, we unpack that source and put it into a separate read-only directory, and you get redirected to that, and you can go over the whole file, and it's actually pretty useful to do. But all that works. I think find references works also, but I haven't demoed that, and I wasn't checking that because there's some issues I see from time to time happening in the Eclipse client still, but there's still a lot of work being done on the client. And from we have a separate plugin for metals that you can, if you go to metals Eclipse website, there is information. Scala meta / metals Eclipse. I'll give you all the links at the end, so it's not important right now. But it is a separate plugin. You can install it, and it works out of the box. Obviously, there's some issues still. Okay. The other thing I wanted to talk about is that we actually managed to make it work in Eclipse IDEA, which allows any VS Code plugins to work. And you can go to that link to test it out on your laptop. It's also, if you go to tgodzik, that's my username /metals_sample, there's a link there, so you don't have to go through the whole link. But there's a sample. It opens Gitpod and opens that workspace in Gitpod which is works on Theia, and it works pretty well, honestly. I was testing it. I have some more examples later on with Theia, but all of our features work there. So this is pretty amazing, and it's really nice for people starting with Scala, for any kind of Scala bridge or something like that, because you can just start working with it. And I see some great potential if we cache classes, like compiled classes, because it could enable developers to work out of the box. They just click on a commit and work with that commit, with everything compiled, and that would be pretty amazing experience. And it shouldn't be too hard because all the pieces, new pieces of the new puzzle are already available. Okay. Now I'd like to talk about the latest things that I said are available in the snapshot. So first of all, importing into Bloop was a bit difficult for us because we needed to add automatically the semantic DB plugin. We worked with Jorge to actually make Bloop download the right semantic DB plugin version whenever we connect to it. So Bloop detects its metals and just downloads, adds all the needed properties to the compiler, and it works, which is pretty amazing because because adding automatically the compiler plugin in each build tool is different, and sometimes it's like, for example, in Maven, I didn't actually do it because it would mean I would parse XMLs and change people's XMLs, and I really didn't want to do that for people. And there was some complex things going on for the other build tools. Now it's the only thing we need to invoke is the plugins that generate configuration files, and that's it. So it will also work for any new build tool. For example, for pants. We're also working on pants integration. That's from the guys at Twitter. All right, go to implementation. So actually, we reused the indexing for references, and there's no noticeable impact on creating the new inheritance index, I would call it. That's the index with all the information about which class extends to which class. And it works for overloaded methods. It works with generic types. It works for local and library symbols. For library symbols, it's a bit slower because we need to load information about the whole class path. But for workspace, it's pretty snappy. We tested it on Akka, and it managed to find all references to receive in 200 milliseconds, which was around 600 receives inside the code base. So that was pretty nice. All right, that's an example. That is an example in Eclipse IDEA, because unfortunately, go-to implementation doesn't yet work in the Eclipse IDE client, but it works pretty well in IDEA, and I haven't found any big issues. I'm really amazed that it took me like half an hour to figure out everything and to make it work. So I mean, kudos to the guys at the IDEA team, because this is pretty amazing. Okay, next thing there's a trio of protocols in my presentation. There's another one, which is debug adapter protocol, which abstracts the it creates a generic debugger that enables you to connect to any underlying debugger implementation. So any kind of client like VS Code, IDEA can use that to run or test any kind of code. So basically, it only works with run test for now, but we're also intending on adding breakpoints and then adding all the niceties that are available in any debugger. And the best thing about it is once we implement it in Metals or in Bloop, because most of the debugging is actually implemented in Bloop, we'll just have to add some more information for Bloop itself using the source code, because Metals knows about the source code, while Bloop only knows how to compile stuff and run stuff. It will work for any client that implements the debug adapter protocol, which also is very nicely specified. And I mean, IDEA already implements that. That's what. Oh, that's a short overview of how it works. So it's not actually that complex. Like Metals know ask the Bloop server about, hey, where are the main classes or test classes? Bloop knows about it because everything is compiled, so it gives us the information about where we can put code lenses, which code lenses are just added like annotations that you can click on, which will be run or test. The client then says, hey, I want to run this one, and sends the request to Metals. Metals forwards it to Bloop. Bloop sets up the whole session and then just communicates between the client and that debug adapter that is running inside Bloop, and until it shuts down or is canceled. And it works in Theia. There's some issues of not everything being printed into the debug console, but for sure everything is working because I see that everything is in Metals logs, which are the LSP logs, the LSP server logs. But I guess the Theia implementation of debug adapter proxy, I think, is pretty new. So there might be some issues. It could be also on the Metal side. We'll probably need to figure it out. But I'm pretty sure it's just a race condition of the debug console being closed while some more information is being sent, because that's a pretty quick program. But it works in Theia, and as I said, kudos to those guys because it's pretty amazing that it works. All right, next on the roadmap. So there's a lot of things we are working on. First one is go to type definition. So not just go to definition, but also go to the type of whatever symbol we are on currently. There's also a lot of people asking about rename symbol. And since we have go to implementation done, it unblocked rename because we need to know about the implementation to rename any classes or methods. We get next with debug adapter protocol, we want to add breakpoints. We want to add a better test interface for both Eclipse and VS Code so that it can be presented not just in the debug console, but also nice as any IDE would show it. So it currently just the same as if you started to run anything inside of your build tool. It just shows a summary of what is happening, and that's it. But we want to make it better so you can rerun or watch your code, so you could just click and watch the code for changes and run the test each time the code changes. Because I mean, I would use that, and a lot of people I work with would want to use that. So next thing is Dotty, so Scala free support. We were actually working 2 weeks ago with Martin to provide the integration with Dotty in Metals, and we got a pretty good proof of concept working. There's also a new flag in Dotty that will create semantic DB files. When we have that, it's actually will work out of the box. The only difference being, for now, most of the features will come from the Dotty presentation compiler itself and not be enriched by us in Metals. So, but that's an ongoing effort to make everything, to have the full parity between the Metal features and the Dotty features. And last but not least is PANT support, which Twitter is pretty interested in, and they're actually working on that. Okay, whatever you would like us to work on, there's the additional repository called Metals feature requests. You can vote on stuff, you can add features that you want, and we'll try to work on those. It's not always that we just use the highest voted one, because sometimes the highest voted one might be difficult to actually implement, and it might be better for people to have something lower on the list implemented but quicker. So, but that's the list we look at when we want some new features, and where people can tell us what is interesting. Like, for example, the information about Theia I got from people wanted it to work actually in Che, but it's very similar topic. So when I started looking at Che, I also discovered Theia and all that. Thanks to all that, it's working Theia now. it wasn't very difficult, obviously, but without like people telling us what they want, we wouldn't be able to even know about it. Okay, so if you have any questions, there's Olaf, the author of Metals, actually did a talk on Scala Days. You can, the link is not very easy, but you probably can just search for Scala Days, Olaf, or Metals talk, and it's on YouTube. There's the Metals documentation on the scalameta.org website. There's Bloop documentation, and you can also follow me on Twitter or shout at me. I'll post any kind of updates on new features and new releases there. So yeah, there's actually that was the intention, to show the Slido app with the questions. But since it's not that many people, if you have any questions, please let me know. Not sure about it, because that needs to be implemented on the client side. For sure, I know Intellij it's already working, and I'm pretty, because like the debug adapter protocol is also from Microsoft, and it's very closely connected to anything that uses LSP. So I'm pretty sure that people doing work on the Eclipse client will want that to also be included. Sorry? Yes, yes. I mean, they're doing still some work. There's still some, I mean, the version currently, I think, is 0.12, so it's not even a full release. It's still, but all the features I showed you in Eclipse are already working, but you might want to, for example, try Theia or try Visual Studio Code until Eclipse is fully supported, if you want to use Metals. Yeah. Any other questions? Okay, so, yeah? I should have told you that. So, like Scala Meta, it's under the Scala Meta organization, and it's LSP, so Scala Meta LSP, Metals. It wasn't my idea, but I think it's a pretty cool name. We can name our releases after metals. So the next one is Cobalt. Cobalt is pretty neat. Okay, last slide. So about my company, we're VirtusLab. We're actually doing a lot of different things. We're helping different companies with some big data. We're helping different companies with tooling. For example, we're working with Scala Center on tooling. We're working with JetBrains on some tooling. So we're actually developing the Kotlin plugin for Eclipse. I think we got experts in most of the things that you see here, plus any tooling that you might think of. We also organize a Scala tooling conference, that's Scala Sphere, which is a part of a bigger conference, Sphere IT, which we actually did 2 weeks ago. And we had Martin Dersky there to talk about Dotty, which was pretty nice. But yeah. So shout out to my company because they sponsored me, and that's it for me. Thank you for attending, and hope it was something informative for you.